Hi, we're looking at numbers 32 through 35 in this segment. Number 32, I think, was frequently missed, not because students didn't know what they were doing, but because there was an error in the question. I think it said find J instead of find X, but the answer was recorded for X. But we have two triangles here that we're told are congruent, and again, through the congruency statement, we can show and see which angles correspond with what, because corresponding angles are the vertices that for those angles are written in the same order. So I know that angle M, corresponds with angle H in this triangle because they're both in the first spot. And then L with K and P with J. So when I look at these triangles, I'm looking for X. That's part of the expression representing the angle measurement for P, angle P. And when I look at my congruent statement, angle P corresponds with angle J. They're both in the last spot. So I don't have J. To solve for a variable, I need an equation, so that means I would need a value for J to set up an equation. So knowing that all three angles of a triangle add up to 180, I look at these two angles, 90 and 54. I take them from 180, and I have 36. So angle J is 36. Angle P is 36 because they're corresponding angles in congruent triangles. So that means that 2x is also equal to 36. So when we solve for x, we get 18. Number 33, we're told that triangle ABC and XYZ are similar. Angle A, the measurement of angle A being equal to the measure of angle X, and the measure of angle B equal to the measure of angle Y. So that means that we have two angles in one triangle congruent to two angles in another triangle. So the angle-angle similarity postulate tells us that these two triangles that I'm diagramming or illustrating what's given here, these two triangles are similar. Knowing that they're similar tells me that the ratio of corresponding sides are equal, or that the corresponding sides are proportional. So I can use the properties of proportion to find the unknown value. They're asking for xz. Okay, so I drew two triangles, and I labeled them the same way so that I could see corresponding sides and corresponding angles. I start here with x, so x, y, z clockwise. Started here for x, so I'm going to start here for A, go A, B, C clockwise, and then I labeled what was given. And I see, according to my similarity statement, I see that xy, the first 2 points here, correspond with AB. So the ratio of 9 to 7 has to equal the ratio of another pair of corresponding sides. I see that xz, first and last, corresponds with AC, first and last. Okay, so this ratio, 9 to 7, has to equal the ratio of x over 10. And so I'm just going to solve for x, that number that goes there, to give me a true statement for these two ratios being equal. When I solve for x, I have found the length of xz. So remember, the cross products of proportions are equal, so I'll use that to solve for x. 7 times x, if I can get this arrow moving, 7 times x is equal to 9 times 10. Get x by itself divided by 7. 90 divided by 7 is approximately 12.9. So I have found the approximate length of xz. Number 34, explain why the triangles are similar, then find the value of x. When I look at a figure like this, I should immediately recognize I've got vertical angles here, and I know that they're congruent. So the angle similarity postulate tells me these two triangles here shown are similar. And if they're similar, then the ratios of corresponding sides are equal, and I can find x that using proportionality. So I just need to make sure I know what corresponding sides are. I can pair those up properly. So, obviously this side goes with this side corresponding. So we have 12 and 7. Those sides correspond. And then notice my angle placement. I've got an angle with 1 mark here and 2 marks here. Okay, an angle with 2 marks here and 1 mark here. So this side corresponds with this side, and then this side corresponds with this side. Remember, when you're building your ratios, to build them in the same order. So I've got, the way I did it is I did x over 8. So x over 8 has to equal 7 over 12. Okay, same order, small over large, small over large. I can't say x over 8 has to equal 12 over 7. X over 8 equals 7 over 12. Cross multiply, 12 times x is 12x. 8 times 7 is 56. Divide 56 by 12. I've got 56 goes into 12 4 times with a remainder of 8. Okay, so 8, and I'm dividing by 12, so I have 4 and 8 twelfths. and that reduces down, 4 goes in 8 twice, and 12 3 times, so that reduces down to 4 2/3. So angle-angle similarity postulate tells me they're similar. 4 2/3 is the value of x. Number 35, I see that the bases of these two triangles, I've got triangle DBE within triangle ABC. I see that these two triangles, the bases are parallel. So that tells me, these two sides are transversals, and corresponding angles we know are congruent. Corresponding angles being in the same position of intersection. Okay, this angle is in the same position of intersection as this one when the transversal going through these lines. Okay, so that means angle-angle similarity postulate tells me the smaller triangle is similar to the larger triangle. So I can use proportionality to solve for x. The ratio of DB, for example, to AB has to equal the ratio of DE to AC and also BE to BC, but we don't need to deal with that in this problem. So the ratio of BD has to equal the ratio, or the ratio of BD to BA has to equal the ratio of DE to AC. So BD is 6, BA is the 6 and 4, which is 10. So we have a ratio of 6 over 10. That has to equal a ratio of 8 over x, and we'll solve for x to find the value that gives us a true statement whether these two ratios are equal. So 6 over 10 is equal to 8 over x. We cross multiply. 6 times x is 6x. 8 times 10 is 80. 80 divided by 6, 80 goes into 6 13 times with a remainder of 2. We're dividing by 6, so that's my denominator. 2 over 6 reduces to 1/3. So we have 13 1/3 for x for these similar triangles. We found x.